Hi guys, this is week 16, the last two lessons of the entire year. So let's go ahead and jump right in. So lesson 119, we are looking at complex fractions. So again, if we remember that a fraction is just division, then this shouldn't be too difficult to kind of comprehend. We have a number in the numerator and a number in the denominator, so we're just performing division. So we've worked with, where we have integers, positive and negative, but it's not always going to be, obviously, an integer. We can have irrational numbers in the numerator, the denominator. We can have negative numbers. We can have decimal numbers. We can even have fractions in the numerator and denominator. So we will look at these. So again, an example of a complex fraction, well, 1/5 in the numerator, not the fraction itself. There's a fraction within a fraction in the numerator and the denominator. Mixed number in the numerator over a whole number over a mixed number. So again, that's just an example of a complex fraction. So it's not just 1/2 or 3/5 or 5/3. It's, we got a whole number, really a non-integer in the numerator and possibly the denominator. But again, if we just remember that it's division, it's not going to be that overly difficult. So a couple different ways we can look at this. If we have 1/5 over 2/3, and so this is my numerator and this is my denominator. How I would go about doing this is I would say this is just division. Well, this is 1/5 divided by 2/3. Remember, keep, change, flip. And dividing by a fraction is the same as multiplying by the reciprocal. Right? So 2/3 becomes 3/2. And we end up with 1 times 3 over 5 times 2. So 3/10. That's the way I would go about doing it. To cancel out the 5 and the 3. So the 5 in the denominator of our numerator and the 3 in the denominator of our denominator, they multiply it by 15/15. Because 15/15 is still equal to 1, so we're not changing the value. But that cancels out the 5 and the 3, and then we're left with 3 times 1 over 5 times 2. So we get 3/10. I think doing it this way, for me, is a little bit easier because it's just division. I'm not having to think of these common denominators and then converting to just multiplying the end. I'm just seeing this as division and then performing the division. But either way, we're going to get to the same answer if we do everything correctly. So again, dividend and divisor. Again, how I remember those is divisors in the denominator. So we don't use those, at least I don't use those terms all the time, but it's important to remember what's the dividend and what's the divisor. And then, again, the way we looked at it, we end up with 3/10 doing it that way as well. Now, let's say we have an expression in the numerator and denominator. Again, we've talked about how expressions in the numerator and denominator, we treat them as their own group symbols. So even though this is division and we have addition, typically, yes, we divide before we do any addition, but we need to add because both of those, even though we don't have the parentheses, both of those are grouped symbols. So we perform the functions first and then simplify at the end by dividing. So let's go over here. We have 1/2 plus 1/3 over 1/3 plus 1/4. And so we have to add up here. Again, we got to get common denominators in order to add. So 2, 4, 6, 3, 6. So 6 is our least common denominator. I know we've worked with that before. So we multiply top and bottom by 2. 2/2 is just 1. So this gives us 2. 6. Multiply this by 3/3. So this would give us 3, 6. So 3 plus 2 is 5, still over 6. And down here, we would make this 4 12s because 3 times 4 is 12. That's our least common denominator. And this would become 3 12s. 4 plus 3 is 7 12s. And then again, this is division. So 5 6 divided by 7 12s. We're going to keep, change, and then flip. Dividing by 7 12s is the same as multiplying by 12 sevenths. 6 goes into 6 and 12. So we end up with 5 times 2 is 10 over 1 times 7. So 10 sevenths. We could have also multiplied by 12 over 12 to get these to be whole numbers to cancel out the 2 and the 3 and the 3 and the 4. But again, it may not work out that easily for every example. So I think just treating the numerator and denominator as their own group symbols, reduce it until you can't. And then once you got it as simplified as possible, then you're just dividing. All right, so 28 and 4 sevenths percent. And 28 and 4 sevenths percent means per 100, so over 100, and we're going to convert it to a fraction or a decimal. So again, we're still dividing. We want to, anytime we're working with mixed numbers and we're multiplying and dividing, we want to get this into an improper fraction. So 28 times 7 is 196 plus 4 is 200 sevenths. Okay, dividing by 100 is the same. Again, we could write this as 100 over 1 if that helps us to see we're going to multiply by the reciprocal. Dividing by 100 is the same as multiplying by 1 over 100. So 200 sevenths times 1 over 100. 100 goes into 100 and 200, so I'm left with 2 times 1. It's 2 over 7 times 1, 2 sevenths. We'll do that practice set together in class. And then our last one, our last one is when we're rationalizing a denominator. So let's say we have an irrational number in the denominator and we want to get rid of it. We can't just take it away, but we can use what we know about manipulating fractions and using any number divided by itself is just 1, using that same concept to rewrite these. So let's say we have an isosceles triangle. That means 2 sides are the same, and these angles are both then 45 degrees. The hypotenuse is 1, and so we're given the lengths, express the length with a rational number. So we have express the length. And so we have our triangle has a length of 1 over square root of 2. We could do that, but obviously dividing by an irrational number is going to give us an irrational number. So we're not going to somehow magically make it rational, but we can get this out of the denominator by multiplying by this fraction by square root of 2 over square root of 2. Because again, any number over itself would just be 1, so this is still equal to 1. So we're not changing the value. 1 times the square root of 2, just the square root of 2. And then square root of 2 squared, because we're multiplying by itself, we're squaring it. That would give us a square root of 4, which would come out to be 2. And again, we could check that and make sure those are, you're wondering, is that right? Okay, well, we can always use the calculator to help us. So if we do 1 divided by the square root of 2, and we get that decimal number. If we do 2, what was our square root of 2 divided by 2, make sure you get out of that radical sign. We get the exact same thing. So these are equal, which we know, but we could go in and check if we needed to. So all we did is it's still irrational, going to go on forever, but we've taken the irrational number out of the denominator. Now we have an irrational number in the numerator, but it's out of the denominator. And so if we look at these, example 2, we have three over the square root of 5. Okay. We're going to multiply, and we want to make this 5 essentially, so we need to multiply by the square root of 5. So that's going to be the easiest way to get a perfect square, take the square root of it, and then make it a rational number. So we have to do square root of 5 over square root of 5. This becomes the square root of 25, because 5 times 5 is 25. Square root of that is 5. And we can't reduce anything else, so we're done. Uh, 6 over the square root of 3. Going to do the same thing. Square root of 3 over the square root of 3. That's 3 times 3 would give us 9, so the square root of 9 is 3. And then in this one, we can reduce because 3 goes into 6 2 times and into 3 1 time. Okay, so we can do this since this is multiplication, okay, and this is division. Those have the same priority, so we can reduce it. Just like if it was, 4x over 4 or something like that. There's like a coefficient. We can go ahead and reduce that. So 2 root 3 over 1, or just 2 root 3. And the square root of 3 over the square root of 2, we can multiply by, again, we want to rationalize the denominator, so we could rationalize the numerator, but we want to rationalize the denominator. So root 2 over root 2. Okay, we multiply these together, so it'd give us 3 times 2, which is 6. Square root of 6 over square root of 4, which is 2. Okay. And we can't reduce that because this is under a radical sign. So that would be as far as we could go. And again, we don't want to just put it in a decimal number because they're irrational. It's going to go on forever. We want to keep it in radical form, but you can always check to make sure, like what we came up with for C, if those put it into our calculator are the exact same numbers, not just close. They're going to be the exact same numbers, and we know we did it correctly. We'll go over those practice set together, and then that means we are done with our 120th lesson. So good job, you guys. We'll be reviewing in class, take our last test, finish up our project, and that'll be it for the year. Good job.